All right. So we still, we will use a simple example. Yeah. But before we work on that simple example, so let's look at the overview of the solution a little bit. Okay. Use the counting data to sort the array. So we assume we get the counting data already. Yeah. Assume that an array take integer values, yeah, in this range. Okay. Then we do the counting, the first step. Okay. So for value 0, suppose the counting value is C0, 1, C1, and so on. Okay. The last value K, the counting number C sub K. All right. Then we want to rearrange the original array elements in this new array. Okay. So when we make the arrangement, so we want to put those elements with 0 value, C0 consecutive positions. This number of positions. Here you can see the counting number closely related to the positions. Next, C1 consecutive positions for value 1 elements, and C2 consecutive positions for value 2 elements, and so on. Okay? Yeah. So here you can see that's the observation we have when we rearrange the array elements. Yeah. So here you can see the main thing we need to do, we need to use the counters, the values in those counters to determine the positions. So that's what we need to do. If we can figure out a way to do this, then we solve the problem. Okay? Yeah, so that's the overview of the solution. Yeah. Next, we need to really fix all the details of the solution. Yeah. Implementation. Part 1. All right. Now we can use a simple example like this. Okay? So very simple. Yeah. Step 1, the counting step. So we use a C array, a counter array C array, because the value in the range from 0 to 5, so we arrange 0, 1, 2, 3, 4, 5. Okay? Yeah. 6 locations. Yeah. 6 counters. Okay? Yeah. 0 first. How many zeros? 2. How many ones? 0. How many 2s? 2. How many 3s? 3. 0 for 4. 1 for 5. See? Yeah. So step 1, we finish the counting in, one scan. Yeah. 1 for loop. Yeah. Step 2, accumulating these numbers. Yeah. Why we do accumulating step? Here you can see, if we do accumulating step, we can really get the position information in a straightforward way. Yeah. So you will see the numbers we get directly connect to the position number. So that's why this step also important. Yeah. How do we do the accumulating? Yeah. First one, same number 2, but second one, accumulate the first 2. So 0 plus 2, still 2. Okay? Yeah. The next one, 2 plus this 2, 4. Okay, yeah. Next one, 3 plus 4, 7. 0 plus 7, 7. 1 plus 7, 8. Okay. Now, this accumulated numbers can give us more direct relationship for the position information. So we can use it to arrange the array elements in a direct way. Yeah. Let's see. Yeah. So first, these accumulated numbers give us initial positions of the array elements with the values. With the values here. Initial positions. After that, we keep updating the position numbers until we arrange all the elements. So now, let's do the arrangement. Step 3, arranging. So, when we do arrangement, we work in the reverse order. Reverse order, yeah. So now, the B array, so that's the destination array. Yeah. So the array get all the elements sorted, so that's the B array. So now we place the elements from A array to B array using the information from the C array. Okay, so let me work the details of that one by one. Okay, all right. So first, when we see 3, let's go to the C array 3, the index 3. Okay, the value is 7. That means the position is 7. So we should place that element at position 7. Okay. After that step, we decrease the position number under 3 by 1. So we get a 6 value and cross out that element just processed. Next one, 0. So you go to the 0 index of the C array. You see 2. That means you should place that 0 element in position 2 of the B array. Okay? Yeah. Then decrease the counter by 1. Decrease that accumulated C number by 1. Okay? Then you cross out that element. Next one, 3, but this time the position number is 6. So you place it at position 6. Then decrease 6 to 5 and cross out that value. Yeah. Next one, 2. So you get 2, 4, position 4, right? So you go place it in position 4. Decrease 4 to 3 and cross it out. 0, position 1, so you place it in 1. Decrease the 1 to 0, cross it out. 3, position 5, put it in position 5. Decrease 5 to 4, cross it out. Okay? So the 5, under 5, 8. So you place it in position 8, reduce number 8 to 7. Cross it out. The last one, 2. For 2, right? 2. Position number 3. So you put it in position 3, reduce it to 2, and cross it out. Because you processed all the elements in the original array, so you complete the processing. So you get the whole array sorted, carrying the satellite data. Remember? So when we do that, we do not throw away the satellite data. We always carry the satellite data. Okay, so that's why we need to do it in this way. Okay, yeah. So now let's look at the efficiency, the performance of this method. Because we need to scan A array once, B array once, each one big theta of n. Okay, yeah. Then C array once. Actually, C array, more than once. Yeah, because accumulated, right? So counter, then accumulated. So now you can calculate. Yeah, because K is in big O of n, right? In big O of n. Yeah. So we should have this C array processing also big theta of n. So putting everything together, the final overall efficiency is still big theta of n. Yeah. So it is very efficient. Yeah. So we get a very good solution for the special type of data. All right, so we complete part 8.3. Yeah. We have one part left, 8.4 left for this lecture 9 part A. All right, so